Welcome to our first lesson in discrete mathematics. In this lesson, or in this video rather, we are going to be looking at propositions. Now, what are propositions? A proposition is a statement that is either true or false, but not both. So, with that definition in mind, will the following be propositions? 2 plus 3 is equal to 12. Now clearly this is a false statement, and as such we can clearly identify this is false, and hence this is a proposition. X plus 7 is equal to 13. Now you might be tempted to say that yes, this is a proposition. However, let me ask you, what is x? We have no idea. X is some unknown. Yes, if x is 6, this would be true, but what if x is some other value? Therefore, this statement here can be both true or false. So since it can be both, it means that it is not a proposition. Kingston is the capital of Jamaica. Once again, we have a statement that we can determine to be true or false. So we know that in this case, it is true, and hence this is a proposition. Where are my keys? Now, if you look back at the definition of proposition, it says that a proposition is what? A statement. A question cannot be a statement, and hence where are my keys is not a proposition. We'll now move on to connectives. Now, connectives are used for making compound propositions, and we have the main connectives there listed on the screen. So we'll start by looking at the conjunction. Now the proposition P and Q is called conjunction of P and Q, and it is denoted as shown here. The truth value of the compound statement P and Q, it is true if both P and Q are true, and it is false if either P or Q is false. Hence, the only time this is true, the conjunction is true, is when both P and Q are true. Now this here, what we have here, is what we call a truth table. Now the truth table takes into consideration all the possible combination of our propositions. Alright, so we have our two propositions P and Q, and the proposition can be either true or false, remember. So here we have P being true, Q being true, P being true, Q being false, P false, Q true, Q false, P false, Q false. So that's all a possible combination. Now the only time the conjunction is true is when both P and Q are true. The next thing we'll be looking at is the disjunction. The proposition P or Q is called the disjunction of P and Q, and it is denoted as shown here. The statement is true when P is true, Q is true, or both P and Q are true. So once we're dealing with some true, the disjunction will be true. So here we have P, Q, true, true, false, false, true, false, true, false. So this takes into consideration all possible combination, and remember the disjunction P or Q will be true once we have some truth value with P or Q. So if both of them are true, or either one is true, it will be true. So this is the truth table for P or Q. So the only time this is false is when both are false. Let's look at the negation. So if we have some proposition Q, the negation of Q is denoted. So this is one way to denote the negation. There are other ways that we'll examine over the course. And it is read, it is not the case that Q. So whatever Q is, whatever proposition Q is, the negation of Q is read. It is not the case that whatever Q is. The truth value of negation Q, whereas not Q, is the opposite of the truth value of Q. So let's look at we'll look at the truth table later on. So we'll look at some examples. Let P and Q be statements Sheng is a singer, and Q be the statement Sheng lives in Jamaica. Write the following using symbols. So what we want to do here is we want to use the symbols for the conjunction, the disjunction, and the negation. So we want to write the statement Sheng is a singer and she lives in Jamaica. Now what is this? Clearly, because of this and here, we know that this is a conjunction. Sorry. So this is just P and Q. The other part, so Sheng is neither a singer nor does she live in Jamaica. Would you like to go ahead and try that? You can pause the video and try that. So Sheng is neither a singer nor does she live in Jamaica. It's a combination of two things. It's a combination of negation P, because negation P says Sheng is a singer. So P says Sheng is a singer. So negation P will say that Sheng is not a singer. Nor does she live in Jamaica. Proposition Q says Sheng lives in Jamaica. Hence, the negation of Q would be that, or the opposite of Q is that Sheng does not live in Jamaica. So, in symbols, this is just negation P and negation Q. For part C, it says either Sheng is a singer or she lives in Jamaica. Here, clearly this or here, we see that, hey, this is a disjunction. So, this is just P or Q. We will now turn our attention to the conditional statements. So let P and Q be propositions. The conditional statement or implication, so P implies Q, is the proposition P implies Q, or it can also be read if P then Q. And here we have the truth table for the conditional statement. As you can see, so P implies Q. This is only false when P is true and Q is false. So we have a number of interpretations for the implication statement. So P implies Q, if P then Q. Q is necessary for P. A sufficient condition for Q is P. P only if Q. Q when P. And also Q unless not P. Now all of these are ways that we can represent the conditional statement. So if you have some statement in the form, say something is necessary for another thing, so one proposition is necessary for another proposition, this is the same as saying P implies Q. So let's look at some examples. So let P be the statement Tom passes discrete math, and Q be the statement Tom will graduate. Express the statement P implies Q in words. So you can use the notes from the previous slide. So we can write P implies Q in any one of the following ways. So we can say if Tom passes discrete math, then he will graduate. We could also say Tom will graduate when he passes discrete math. Another way we could say it is Tom will graduate unless he does not, well, there should be a not here, unless he does not pass discrete math. Let P and Q be propositions. The proposition Q implies P is called the converse of P implies Q. The proposition negation P or not P implies not Q is the inverse of P implies Q. And the contrapositive of the implication P implies Q is the implication not Q implies not P. So let's look at an example. Consider the conditional statement. If Tom can swim across the river, then he can swim across the lake. So we first identify our propositions P and Q. So P is Tom can swim across the river. Q is Tom can swim across the lake. Now the converse, so remember the converse would be Q implies P. The converse would be the statement, if Tom can swim across the lake, then he can swim across the river. The inverse, if Tom cannot swim across the river, then he cannot swim across the lake. Remember, this is now not P implies not Q. And the contrapositive would be if Tom cannot swim across the lake, then he cannot swim across the river. And that is not Q implies not P. So that's the contrapositive. The biconditional statement. Now the biconditional statement is true when P and Q have the same truth values and this false otherwise. So here we have the truth table for the biconditional statement. As it's stated, it is only true when both P and Q have the same truth value.